So again, welcome everybody. There's my website at the bottom if you're interested in looking me up later. And this seminar is aimed at people who are either starting or early career Java developers. So people who are really getting started. It's a fairly low level presentation, not too detailed, but you want to improve. You want to get better at doing Java. And that's why we're here really today, is to help you get better at Java. What we're going to cover is really it's kind of like two separate topics joined together. The first half is an overview of the Collections API, which is a very, very good and flexible way of keeping track of large numbers of objects in Java, or values, I should say, in Java. And the second half is on an introduction to design patterns, which are ways of organizing your code. It's physically two different presentations. You're going to see two different screen backgrounds during the two halves, because I have them in separate presentation files, but they're all on the theme of better Java. And like Josh said, I'll be happy to take questions at the end. You can put them in the chat as they occur to you, but bear in mind I won't get to them until the end, in part because I can't see the chat. I can't see the chat session right now because I've got PowerPoint on one side and PowerPoint notes on the other, and I only have two monitors. So you'll have to bear with me and hold your question, or put your questions in the chat anytime, but bear in mind that I won't be able to get to them until the end. So without further ado, I'm going to switch presentations here. Sorry, I was rehearsing it before and I forgot to reset it. There we go. Starting with collections, data structuring. So keeping track of data in memory. If you only have a few, say you're dealing with customers or people or whatever they are, you only have a few of these objects in your application, then congratulations, because you're writing a very simple application and you won't have to use the collections. But assuming you have maybe 24 or 100 or 1,000 or something, then you need a stronger technique than just giving them individual names. And that's where the topic of data structuring comes in. So there's two levels of doing data structuring in Java. First off, there's arrays, and second is the collections classes. And arrays are, well, back up a little bit. Java is one of the languages in which arrays are separate from the collections. If you were instead of Java, if you were learning Python, for example, or Dart, which is in the Flutter that I'm talking about next week, you would find that arrays and lists are the same thing, and they're much simpler. In Java, they're very specifically different, and the array types have the benefit that they're built into Java, so they are more efficient. On the other hand, there's some limitations on them, but you can make arrays of anything. You can have arrays of integers or arrays of person objects or arrays of date objects or whatever you like. And to use arrays, you have to declare them as an array type by saying, for example, int data square bracket in the middle of the slide. And you also have to initialize it by saying new int and giving it a size. And that size is the maximum number of elements that can be placed in that collection, in that array. And then we can iterate through it, inserting elements into the array. Assume we have a method which is sort of pseudocode, get next data from someplace, that will give you objects. Maybe it's reading them from a file or getting them from a network or whatever, makes no difference. We're just storing them into the elements in the array sequentially. If, on the other hand, you know all the elements that need to go in the array at compile time, you can use an explicit initializer, which is just, instead of saying new int or new person or whatever, you simply put open curly brace, as I've done here on the top part of the slide. Int month length, those are the months in the non-leap year, in the normal calendar that we use, the Gregorian calendar. And then we have, at the bottom, we have a method of iterating through the array and printing out each element of it using a for loop. And that's fine. Array indices begin at 0. So if you want human visible numbering, you have to add 1 to the array element numbers. That's the I plus 1. You can make arrays of anything. Like I said, here's an array of person objects. We have this funny thing in English that one person is a person, but 2 or more is a people. So person people equals new person. And again, I'm giving an upper bound of 100 and then reading them in from someplace and stashing them into the array. When you are wanting to access all the elements of the array one after another, you can use the so-called for each loop, which is assuming you have this array of data, you can simply say for int j colon data. If you're reading this out loud, you say for j in data. But when you're talking to the compiler, you use a colon instead of the word in, which is a bit odd, but it's Java. What can I say? That will pick each element out of the array and assign it to the variable j one after another, and each time it'll do the body of the loop. So whatever that is, print it or process it or compute something on it, we don't care. We're just talking about the iteration here. 2D arrays, you can have an array. It's technically, Java calls this an array of arrays, but for normal people, we think of it as a 2D array, and it's an array of 100 arrays of 10 integers. So we've actually got 1,000 integers there, and we could iterate through both dimensions and assign values somehow. Notice that .length is a built-in attribute. You cannot assign to length, but you can use it in expressions. So summary of arrays, they're simple. They're efficient because they are, they're built into the Java machine. It knows how to interpret them very quickly. The downside is, what if the user gives you 101 objects and you've only allocated 100 in your array? Well, either you'll get an array index out of bounds exception, or if you check for it, you will reallocate the array and use system array copy. And there's a example of doing that. The file names, all the file names here are in my GitHub, which is publicly accessible. I'll give you the URL for that at the end. So just a reference there to array 2 for reallocating an array. But there is, in fact, a better way, which is to use the collection. And the collections classes provide way more flexibility and in fact implement most of the classical, what are called the classical data structures. If you look at a university curriculum on computer science, you'll find there's a whole semester course on data structures. And fortunately, you don't have to take that course now because you're taking this seminar and finding that most of these have been implemented for you by the collections API. So it's a big time saver, both in terms of coding time and in terms of not having to write this stuff. In terms of importing it, this is in java.util. All of these classes are in java.util. And there's actually 3 different interfaces, list, set, and map. List and set have a common parent, which is called collection. And it's, like the name implies, is simply for collecting objects. Now, it's funny, the word collection shows up multiple places because it's a common word in English. It's the name of an interface. Made plural, it's also the name of this overall collection of classes, this package of classes, the collections API. And there's actually a class called collections as well, which we'll meet later, just to keep the confusion going. The third one is map, which is a key and value pair, or an associative array, or a hash, it's called in other languages you might have used. For each of the 3 interfaces, there's multiple implementation classes that you can use. And part of the advanced topic of using the collections API is knowing which one of the different implementations makes more sense for your application. And we'll talk a little bit about that at the end. So here is the complete story of, more or less the complete story on the collection interface. It grows periodically, so this may not be the latest version, but you'll see there's methods in it like size and isEmpty and contains and iterator and to array and add and remove and so on. There's a bunch of methods there. We don't have to memorize them all, thankfully. Presumably you're using a Java IDE that will do code completion for you, so you don't actually have to type all these out most of the time, but you should have a vague idea what's in there. So list is the most commonly used of the three. A list is an ordered set, an ordered collection or a sequence. So it might be a shopping list, things you have to buy on the way home. It might be an address book. It might be a list of people that you're, a list of people that are attending this webinar. It could be any sequential collection. There are half a dozen implementations. The most common is array list. That's what we use most of the time. And it's called an array list because, unsurprisingly, it's like an array. It's like a Java language array, but it's using method calls rather than square brackets to refer to elements. And it has more capabilities. It's more powerful because you can do things like insert in the middle, which you can't do with a regular array, unless you want to write a for loop that moves all the elements over to make room. And similarly, deleting, you have to move all the elements back. But the array list does all those for you. Any list interface will implement all those things for you. And things like find where is this element in the list? And bulk, add, and remove. You can add one collection into another, for example. There's a whole bunch of very high-powered stuff compared with the regular arrays. Other implementations include linked list and vector and a couple of others. So here's what the list interface looks like. It extends collection, and it has an extra add method, which takes an index number. That's for allowing you to insert in the middle. There's add all that allows you to add a bunch of items at a particular location to insert all of one collection inside another. There's get that takes a number, get and set, and a bunch of other methods. This is not necessarily a complete list. These are just the most important ones. So to populate a list, I showed you at the beginning how to populate the array. So this is the corresponding thing for array lists or lists in general. Notice how I declare it. List equals new array list. I declare it as a list so that I won't inadvertently use methods that might be declared in the array list but not in list. And that way, if I later decide that I need to change from an array list to some other implementation, it's much easier. So that's kind of how I recommend doing it. Then I have again, my hypothetical read person from somewhere method. I keep calling that until as long as it returns null, list add. So now, unlike the previous array one, I don't have to worry about how big it is. It can be 10, or it can be 100, or it can be 1,000. And the array list will just grow automatically as long as I keep adding stuff to the end of it. I can also insert at a particular location, like I said, for any value of ix less than or equal to the size of the list. I can add at that index a given object. And like I said on the previous slide, I can add all the collections from one collection into a list, into an array list, using add all or add all with an index. So that's pretty cool. List operations. Does the list contain a given object? Yes or no. There's only two possible outcomes. List.contains. If you just want to know whether a given item is already in a list, contains. If you want to know where it contains it, then instead you call index of, and that will return either the offset within the list or -1 if it can't find it. For sequential processing, you can either use for loops or iterators. The iterator provides a more generic interface, but the easiest way to use it, there's an explicit use of it. Okay, the interface, sorry, I'm a bit off topic here. The interface for iterator has 3 methods in it. Has next, and remove. So the way we use an iterator is to say, while we get the iterator from the collection, first off, And then we say, while the iterator has next, meaning there's at least one more element available to us, give it to me with next. Call iterator.next. And we are here casting this, the return value from next into a person and saving it in the person object. We can get rid of that by using type parameters, which I'll show in some of the later examples. The second major interface in the collections API is the set interface. Now, sets are like lists in quite a few ways, which is why they both, as I said, both inherit from collection. But they have a couple of major differences. One is they do enforce uniqueness. This is in the sense of the mathematical sets that you took in high school algebra. The other difference is they don't preserve order. They don't guarantee to preserve order. So here's an example. We have a hash set created. Again, I've declared the variable h to be, because it's a hash. I've declared it as of type set, but instantiated it as of type hash set. And again, that's my keep it generic way of doing things. Then I call the add method, and notice that I, in this example, hypothetically, accidentally added the first string twice. Well, then if I iterate through it using a for loop, it'll only print out 1, 2, 3. Again, not necessarily in that order, but it will only print those out. I'm also showing here a third way of iterating through the collections. There's a for each method in the collections API. And it takes a lambda expression, which, if you're not familiar with lambdas, they're sort of like an anonymous inner class where you only have to write the name of the variable that's a parameter to the method and the body of the method. So this is just taking the string s and passing it into system out print line for each element in the list. So it's going to take the 1, it might do the 1, the 3, and then the 2. It doesn't preserve order, but each one of those strings in turn is going to be passed into print line and printed out. And this is in setdemo.java in the download. Because it is a set, and if you remember set arithmetic, you also have things like union and intersection. So here's an example. I have created a set with some disreputable characters in it and another set with some other disreputable characters in it. I do the union on them, and that's going to print out all of these names, but only once, each one only once, even though this is in both. And intersect is going to print out just yours truly. And you can verify that by running those examples. The third general interface in this collections API is map. And a map is a set of key and value pairs. And it has, among other things, the same method, some of the same methods from collection like size and isEmpty, but it's different. Most of the other methods are different in their names or their arguments. For example, get now takes an object, and which is the key, and returns the value. So we populate this by putting in a key and a value, and we get out by asking for something with a key. That's the basic usage of it. But there's also a way of getting all the keys, a way of getting all the entries, a way of putting one map into another, and so on. So we want to store values in a map. Here's an example using put. We, again, reading person from file, and we're storing the people by their name, and each name is a reference to the full person object. We can then retrieve from it using the key. If we know a person's name, we can simply call map.get, and that will give us back the person object. To retrieve all the values, it's a bit more work than for a collection. One way of doing it is to ask for the key set, and use the key iterator using has, next, and next. There's also the implicit way of saying for person P in map.keyset, that should actually be, this slide is wrong. I'll have to correct that slide before it gets printed out. We need to call, that needs to be string. The key set is just going to be a set of strings, and we have to call get on each one. So sorry about that. Page 20. I'll make sure that gets fixed up before we go any further. Here's another example, a better way of doing it. The values method returns all the values, and it returns a collection, not a set, because the values don't have to be unique, only the keys do. So it returns a collection, not a set. So map.values gives you all of the values, and then you get the iterator from the values and iterate through that. Another way of getting all the entries is with a map.entry, which is a sub-interface, an inner interface under map. And just the example, if you look at the bottom example, map.entry set gives us a set, and we iterate through that set. And for each one, we call, on the iterator, we call next. Well, it has next, we call next. And then the map entry object has both a key and a value stored in it. So we can actually retrieve the entire map with these 4 lines, or 5 lines. And that's generally the easiest and most complete way of doing it. There's another type of, another class, I should say, in there called a properties, which is a map that is specifically for strings. And we normally use that for storing preferences and things like that. So we construct the properties, put properties into it, say, that's not my real address. We can then retrieve using get property, and now we don't need to cast it because the properties only deals in strings. And there's no hierarchical mechanism here. These dots are just for my convenience. In fact, this one still works even though I made a typo in it. Commonly used for customization. So it's just like a map, but it has a few extra methods specifically for strings, just to make it easier. The other thing with properties is that you can load or save them from a file using a file input stream and a file output stream. So we can say, for example, properties.load, given a file input stream for this file, or p.save, or p.list, which will print it in text form. And in both cases, it's going to be name and value pairs. It's going to print out the key, an equal sign, and the value. So you can actually use that to save, if it's properties that are being manipulated interactively in an application, you can save the latest values into a file. There's a predefined properties object called the system properties that contains information about the runtime environment. And you can say, for example, you can dump the whole thing out to the terminal in one line by saying system.getProperties.list system.out. Saying system.getProperties returns the system properties. As we said on the previous page, properties has a list method, and system.out is the predefined output. So we're ready to go. It might have something like this in it. Java vendor, Sun Microsystems are more likely Oracle these days. Java version, that's an older version. But user directory, that's what the current directory. Operating system name, I ran this on OpenBSD Unix-like system. Operating system version. It's actually going to print like a whole screen full of stuff. These are just a few of the key entries from it. But that's a way of using the collections API to get information about the environment that your program is running in, your Java application is running in. I said that sets don't preserve order, but there is a specific one that does, which is kind of weird. It's called tree set. And the tree set will, you can insert things and it will keep them sorted internally. So if you add these ones here, this one will only go in there once, but if you iterate through them using the key set or the values, you'll get them out. I told it to do so case insensitively, so you get D-A space, then D-A-R, then G, then J, then Van space, and then Vanguard. You can also sort, oh, here's an example printing that, following on from that and just printing them. And we can ask for particular things. There is a first and last, there are methods like first and last in addition to next. And the tail set of a given string gives you elements that are above that in their value. So that would print on the previous page, that would print the that one, and that one, and nothing else. If you're not using a set, but you still want to sort things, there are a bunch of utility classes available. The collections class, I warned you about this before, this overuse of the word collection. The collections class has a bunch of static utility methods in it. The collection singular is the super interface of list and set, and collections plural is this class. So if we want to sort a list, we have our list, we filled it in, and then we call collections.sort on the list. And what that does is it rearranges the elements inside the list so that they are in sorted order. And then we can just iterate through it and they'll come out in the correct order, which is pretty convenient. Comparisons are based on the normal order of the objects in the list. So for strings, it's obviously a string comparison. If you don't want that, or if you're sorting objects that don't have a natural order, you can provide a second argument to the sort, which is a comparator. And a comparator is just an interface that has to return minus a negative value if the first one's low, 0 if they're equal, and plus if the second one is high. And it's called with each pair of objects internally by the sort method. Conversions between collections and arrays. We started off saying that the arrays may be more efficient, will usually be more efficient, but the collections can grow arbitrarily. So what if you don't know ahead of time how many of something you're going to have, but you want the efficiency of an array? So what you do there is you generate the data into a collection, like a list, and then convert it to an array. So there are converter mechanisms, methods in both directions. ToArray is in the collection interface, and AskList is in the arrays class. So you can convert in either direction. Converting a collection to array of object, simply take a given list and call its built-in ToArray method. You can also provide a empty array of a given type, and it will convert it to an array of that type to avoid casting issues later. In current versions of Java, there's something called preferences, which is almost like a property, but it has the additional feature that it's stored automatically for you somewhere that is appropriate to the system. On Windows, it goes in the registry someplace. On Unix, it goes in your home directory in a hidden file, a dot file. This is the one thing that's not in the Java util package. It's in the preferences. But it's very convenient for working with user preferences because it's saved automatically from run to run. and you can just retrieve, person's favorite color or whatever the preference is, without having to do anything like opening files or anything. Just preferences, just they're there. So here's that summary of what's in the collections API. There's collection, which has list and set under it. And for list, there's multiple implementations. We didn't talk much about these, but they also exist. For set, there's multiple implementations. For map, there's multiple implementations. The one in parentheses are older ones that are nowadays mainly only there for special purposes. There's other interfaces like comparable and comparator, and there's the utility classes arrays and collections. This chart is on my website at the URL shown at the bottom. You can download it if you like. And that really is a complete summary of the collections. A few things to be aware of. There are performance implications of using different implementations. So you should, before doing anything too fancy, you should read the Java doc at the beginning of, say, array list and linked list and compare them, or hash map and hash table and so on. In particular, one last thing to be aware of is be very careful if you are trying to modify a collection while you're iterating through it, particularly if you have multi-threaded application where one thread might be reading from it, another thread might be adding or removing. You have to be very careful doing that. If you get it wrong, you'll get a concurrent modification exception. You can read up on that in the Java doc, which is why I said to read the Java doc carefully. That's pretty much it for the first half of our talk, the data structuring. Oh, here's the URL for the example GitHub, github.com/myname, Ian Darwin /Java source. And most of these, I think everything I talked about in this module is in the main source main Java structure subdirectory, kind of a convoluted structure, but it has to do with there being multiple projects in the same repo. So that's it for the first half. Now we'll try and go on to the second half. So design patterns. So design patterns are recurring design elements. So that's kind of a vague definition. They're at a larger scale than small coding idioms like use a while loop to read a file a line at a time, or read system.in by wrapping it in an input stream. Those are like coding idioms that are just one small piece of code. The design patterns are larger structure than that. They involve more code. They're covered in this book, Design Patterns, by Gamma, Helm, Johnson, and Velicities, which is frequently referred to as the Gang of Four because there's 4 people in it. And nobody can remember all of their names or even pronounce the last one especially. But it's a very good book. It's very academic, let's put it that way. It's very dry reading. And there is another book, which I don't have on the slide, unfortunately, which is Head First Design Patterns, which is a much more approachable implementation of a discussion of the implementations. So patterns occur everywhere. And here's some examples from daily life. Just need to move a window here. There we go. So in architecture, we have a skyscraper. If I say the word skyscraper, you immediately picture a tall building, right? With steel and concrete or glass or whatever on the outside. House, you know what a house is. Garage, you know what that is. Within a house, kitchen, bedroom, bathroom, and so on. They're all things that we take for granted. In music, we have symphonies, we have rondos, we have jazz pieces, we have rock music, hip hop, whatever. Those are all general descriptions of a certain type of music. In driving, we have complicated things like left turns and parallel park. In talking, we give a speech or a presentation like this one. We run a meeting. We make small talk. Each of these is a general pattern that requires adaptation for what exactly you're trying to do at the given point in time, and is understood within some domain of human activity. Here's one example from architecture, kitchen layout. What's the one thing wrong with this layout shown in the picture? Think about that for a second. Remember your high school geometry. You have three major elements in a kitchen. You have the fridge, you have the stove, and you have the sink. And there's going to be a lot of others. This one has a little bar table at the left side. But those three elements, now if you remember your high school geometry, you know there's only two possible arrangements of 3 points in the same plane on the floor, looking at the room from above, which is one is a straight line like they've done it here, and the other is, of course, a triangle, 3 points. So the triangle could be a right angle triangle or, scalene or isosceles or whatever, but it's going to be a triangle in most kitchens, most of the ones that you actually go in, unlike this very clever but simple design. And why a triangle? Well, it turns out that it's more efficient because you need to walk between those three elements a lot while you're preparing food. And yet, there's more to it than that. Why is a triangle shaped like this sometimes and like this other times? Because it depends on a bunch of other things. Where does the sink have to be located? It has to be where there's a window, because food prep, you need good light for food safety. And also because washing dishes is really dreary and boring, and you need to do everything you can to cheer it up. But the other thing is the stove has to be where you can locate a fume hood. So it either has to be on the outside wall, as this one does appear to be, or if it's an inside wall, you have to be able to go up through the ceiling to get to the outside, to carry the small particles of fumes that accumulate from cooking, so not going in your lungs. And thirdly, the fridge. The fridge is heavy. You'll know that if you ever tried to move one. So it has to be someplace where there's a floor joist right underneath it, so the floor doesn't sag. So those are the variations and the consequences that you would use in designing a kitchen at a very crude level, obviously. But that shows you that there's a lot of moving parts, and most of them have different scenarios, have different uses of them. So patterns provide a common vocabulary. Like I said, when I say kitchen, you know what I mean. When I say skyscraper, you know what I mean. In terms of software specifically now, they provide a best practice implementation. The patterns that are discussed and documented tend to be ways of doing things that work well, that are established, that are recognized as being the normal best ways of doing things. Patterns boost code readability, maintainability, flexibility. After some practice, you will get to the point where you can look at code and say, oh, that's a whatever pattern. And it'll be written more or less the same way as the last one you looked at. Also, the standard Java APIs and almost all modern frameworks like Spring and Java Enterprise and so on use these standard patterns as well, and in fact implement many of them. So knowing the pattern vocabulary makes it more predictable. You'll be able to better predict how the thing is going to behave. A word of warning, there are a lot of patterns. There's about 24 standard patterns. There's a bunch of other Java-specific patterns, and there's a bunch of enterprise patterns. You probably don't want to try and learn them all at the same time, especially if you're relatively new to Java. Like if you've just taken your first Java course and only been working with Java for a few weeks or a month. You should come back after, you should have at least a few months of working in an object-oriented language before you start diving into this in detail. But do come back to it and learn it. Pick up the Head First Java book, Head First Design Patterns book. The examples are in Java in that book, conveniently. So there's two main sets of patterns, the Java ones and the Java Enterprise ones. The Java ones are, the general ones, I should say, are in the Gang of Four book. And interesting thing about them is that the design patterns book came out in the mid 90s, and so did Java itself. Now, you might think that the Java people read the book and quickly implemented all that stuff, but in fact, these were in general circulation before, starting in the late 80s, let's say. People were talking about and discussing these and so on. So it wasn't surprising that the book, which cataloged them, happened to pick on many of the ones that were used by the same people who implemented the Java libraries. There's also the Java Enterprise patterns, which are specific to web applications and EJBs and so on, the various enterprise components. So starting with a discussion of some of the general ones. Singleton says we want to control access to a resource, and therefore we're going to make sure that only one copy of a given class will exist in a given instance of the JVM. And that is to provide controlled access. So the implementation of that is to have a private constructor and a getInstance method that always returns the same reference. So there's only one, the private constructor makes sure that user classes cannot create their own copies of the thing. And some examples from standard Java, the runtime class and the toolkit class are both examples of this. And those are used in, toolkit is used in windowing, and runtime is used in some of the operating system accesses, like creating new processes and examining running processes, stuff like that. So those are singletons. Factory method, there's actually 3 or 4 levels of factory methods, but the general idea is that a factory method is a method that makes up other classes for you and may determine the type dynamically or at runtime, maybe under configuration file control, or maybe under some other part of your application control. And those are you typically call getInstance to have the factory create an object for you. In standard Java, the examples include the formatting subclasses in java.text and the internationalization. I18N is short for internationalization, the stuff to do with printing out strings, for example, in the correct language that the user expects. So not everything is English, of course. And there's very good support in standard Java for internationalization. There's a chapter in my Java cookbook on how to do internationalization in standard Java. Strategy is a design pattern in which an algorithm or part of an algorithm is left to a helper class, which is going to be plugged in by the caller at runtime. An example that we just looked at in the previous section was collections.sort, where we pass the list to be sorted and the comparator. And the comparator is the strategy object. It says, how do I do a particular part that is the comparison of each of these 2 objects? I'm going to call it on all the combinations to figure out how to do the sorting. So that comparator is a strategy object. Strategy is also called plugin. As in Photoshop plugin, as in the comparator is a plugin for doing sorting. Applets are a plugin to a web browser, all kinds of uses. Delegation is a pattern or delegate, I suppose, is a pattern that provides a cleaner mechanism than inheritance for combining fields. For example, suppose we have a customer and we also have an address class. Well, you could have the address subclass customer, but then you're tightly bound between those 2, and the customer can only have one address. So instead of that, we make the customer have a reference to an address object, and now the customer can have both a billing address and a shipping address. and they're both going to be of the same class address. So people tend to, when they learn object-oriented programming the first time, they tend to overdo it on the inheritance side. So this slide specifically is there to remind you that we don't always have to do inheritance. You can do aggregation instead, which is another name for this. And that customer, not subclassing address, but having one or more addresses is a good example of that. The observer pattern is a way of hooking together different parts of your application. For example, between a data class and its view, if you have something that displays an object. So the observable allows the observer to register with it, and then will notify the observer when the data changes. Now that's in itself is fairly simple. The observer is the foundation of a larger pattern called model view controller. And while I do have another presentation on it, we're not presenting it right now. So briefly, model view controller is what's commonly used in, to give an example, is a slideshow program. So the model is the code that controls the data, keeps track of it. The view is what you see on screen, and the controller is what reacts to what you do. So that's the three-part division between the different parts of the code. And the benefit of that is that the model is self-contained. The view, the nice thing about the view is there can be more than one view involved. For example, in a slideshow program, you have a slide view, a slideshow view, a slide sorter view, a notes view, and so on. And each of those is a view in exactly this sense of model view controller. And you can switch between them. And in a properly written application, a non-buggy application, you never have to do like view refresh after you switch views. Some of you may remember doing that from the Windows 95 era when applications didn't really twig onto this. But nowadays, most applications have this down pat so that if you make a change, so you type a word, you're adding a word to a slide, the controller gets that from your keyboard, receives it, and updates the model so that now the model has that word in it. The model then, using the observer pattern, notifies any and all views so that they all update at the same time, or the next time they get put on screen, however it's implemented. So that's a general division, and model view controller is a normal way nowadays of writing applications, both desktop applications and web applications and mobile applications too. It's a very good division. There's 5 or 6 variations on it, MVP and MVVM and so on. So I'm not going to get any further than that right now in the time we have. Some Java enterprise patterns. One of the best known ones is data accessor. And this is not specific to Java. This is a general enterprise pattern. But the idea with data accessor is that it encapsulates the database access, whether it's JDBC or something else, so that, for example, searching methods return a list of some application-specific object like person or customer or address, whatever it is, from the database. And the rest of the application doesn't know how the data is being stored. So that if you need to totally change the data access, you can do that without affecting the rest of the application. If you ever find an application where they have imports from java.sql all through the code, run away fast. It's or get busy with the refactoring tools, because it's not structured properly. Only the data access code itself should even know about java.sql or Hibernate or JPA, whatever technology you're using. Everything else in the rest of the application should only deal with data access objects and domain-specific objects, nothing else. one view is that Hibernate and JPA. Hibernate and JPA are both higher level than Java Database, JDBC, and they allow you to do things like take a Java object and insert it into the database without having to write a bunch of insert and pull out the individual fields and put them into a prepared statement. They do all that work for you. And some people say that those actually are data access layers. Other people will write a data access layer using them. So that is kind of a gray area trade-off, if you will. Another pattern is the value list handler pattern. And this is for the case when you're doing any large search, whether it's a database or a web search or anything. When you go on Google, right, you type in a word like Java or politician or whatever, you get back, 1 through 10 of 19 million or 28 million or whatever it is, number of hits. They're using this pattern. The idea with value list is that it only gives you a chunk at a time. And that way it doesn't have to go all the way to the data. It doesn't have to bring all 19 million records in from the database, which would totally destroy the application performance, right? So that's why almost all search mechanisms do this, chunking. And the implementation of it is the value list handler. I hope that didn't disconnect my microphone. Nope. So that's the value list handler. The client will call get next or get next with a number, and it'll get back either 10 or that number of objects. Here is a summary of the Java Enterprise patterns from a now obsolete book. So I wouldn't take it too seriously, but some of these are still in effect, but some of them have been kind of obviated by changes in the Java Enterprise technology. Here's a hint. This book has J2EE right in its title, and the term J2EE has not been in use since 2005. So if you ever see a book or an article or anything with J2EE specifically in its title, other than a job you're applying for, then just delete it, right? Because it's out of date. Okay, there's lots more to patterns than this. There's a sorry for the bad hyphenation, stwww.csuiuc. That's University of Illinois at Chicago Circle, I think. That's not quite right, but close enough. Users, patterns.html. The Gang of Four design book by Gamma, Helm, Johnson, and Velicities. The Head First design patterns book. And for the enterprise, I won't recommend the obsolete book anymore, but there's a guy named Adam Bean, who's in Germany, that has several good books on enterprise design patterns. And I would encourage you to check out his website and his books for further reading on these enterprise design patterns. That's just, oh yes, refactorings is code level patterns. It's lower level than we're doing here, but designed to improve code readability. There's a book on refactorings by Martin Fowler, which I encourage you not to buy because it's really aimed at people who are developing tools like Eclipse or NetBeans or IntelliJ to document. It provides the same kind of thing as patterns did, a vocabulary, which is why Eclipse and NetBeans and IntelliJ all have this refactorings menu with many of the same names used for the actions. They got the names from this book. And that is pretty much the end of that. So thank you guys all for being here and listening. I hope you learned something useful today. And we do have a number of other seminars in this series coming up. So feel free to join in those. There's a couple next week as well. And Josh, back to you.
All right, Ian, thank you very much. Those seminars next week are on Wednesday and Friday at 1 till 2:30. Feel free to join us. The link is on our website. Thank you very much, everybody.
Thanks a lot, folks. Thank you.